Thank you for joining me today. So my name, for those that don't know, is Dan Bridgman, and I'm the operations manager here for highway surveys at Socotec UK and Ireland. Some of you may know me from Impulse Geophysics, of whom were acquired back in July 2024 by Socotec UK, and have now been fully assimilated as of December 31st last year into Socotec UK. So today's session is an introduction to highway surveys, specifically focusing on how digital video, ground penetrating radar, geospatial data, and AI technologies are being used to safely and efficiently assess the UK road networks, and also what we're currently doing here at Socotec with regards to these topics. As Kaylee briefly touched on, the structure of the next sort of hour, the next 30 minutes, I aim to cover a few topics. Mainly around how digital video and GPR surveys work, what you can actually do with the data that comes off the back of them, how this sort of data supports standards like CS229 and PAS 2161, some current products that we've got in development here at Socotec, and where we see the technology going next with the likes of AI and machine learning. So aim to have around 30 minutes for my presentation, and at the end, we'll have around 25 minutes for questions, so feel free to note anything down as we go along so that we don't miss anything. So let's start with digital video surveys. So what is a digital video survey? Essentially, a digital video survey provides a safe, efficient, and non-intrusive way of capturing high-quality visual data across a typical network highway environment. Instead of putting people on the road, risking safety and obviously timely traffic management requirements, data is collected at traffic speed using bespoke electronics, vehicle-mounted camera systems, etc. The main aim of these surveys is to give a permanent, repeatable visual record of the network or your scheme, and one that can be revisited at any time to support condition assessment, asset management, and maintenance planning, some of which I'll touch on later in the presentation. Usually, we can deliver all of these objectives of your survey without ever stepping foot on a site. So, specification. Typically, our system captures a multi-view high-definition 4K imagery at a resolution of approximately 3840 by 2160 pixels, giving you a high level of detail required for your inspections. Now, this is not to be confused with a few systems that are out there that quote 4K. However, this 4K is stretched over 360 degrees, which isn't traditionally what we would call 4K. While it's typically known as well as a video survey, and it's always referenced as a video survey, what it is actually a series of geo-referenced frames extracted at an interval of approximately 2 or 4 meters, depending on the client requirements. And then this therefore gives full coverage of the environment around. Everything is then referenced to network sections. This could be PAMs, this could be local, or this could be a specific scheme chainage. If we were to then reference it to British National Grid coordinate systems, or potentially any other coordinate systems that you guys are reporting to, we can see if we can load those in there also. And finally, all of the data is then made accessible through our Socotec Connect Roadshow software, which is currently license free, but I'll touch on this a little bit shortly. A typical vehicle configuration for video surveys. So we collect our data at true traffic speed, meaning there's no requirement for traffic management or any other form of protection. This ensures mainly that there's no disruption to the public. We all get a bit of backlash from the public when road closures are on, so we aim to avoid that with a video survey. Using our proprietary camera systems and onboard electronics, we combine RTK corrected GPS, inertia navigation with dead reckoning, and wheel odometer readings to achieve a sort of sub 10 centimeter positional accuracy, even when traveling at 60 to 70 miles per hour. This includes in-frame measurement. Unlike some of our competitors, our camera system is 100% modular, with up to 9 camera configuration available. And then this basically allows us to truly tailor the setup depending on the requirements of the survey. So, for example, if the survey is specifically looking at central reservation drainage channels, we can point a camera directly at those drainage channels for you to make your assessments. Some typical applications that apply for video surveys. So they're extremely versatile, and that's why they're now used across a wide range of highway applications. Some of the most common applications that we use the video surveys for are things like general highway inspections. This can be looking at excess vegetation and any other sort of reportable elements that you might be able to capture from video. Asset inventory. We can create and update your asset inventory on here. Assets being things, signs, lampposts, drainage, manholes, etc. The next thing is pavement defect management. So we can specifically look at specific defect types on the carriageway itself and report those from video in high definition. Visual condition surveys comes off the back of defect management. So visual condition survey to CS229 specification here in the UK. You can also do vehicle restraint systems, high friction surfacing inspections, road sign condition inspections. So looking at the sign, the plate, the post, the environment around that sign. And then we move on to some of our nighttime video data collection, looking around sign retroreflectivity, road marking retroreflectivity, and road stud retroreflectivity as well. Footway surveys can also be collected in more urban environments, nominally by positioning a camera, looking down at the footway from recording the video on the carriageway. The benefits here are that you don't need to commission separate site visits for different pieces of work. You can generally obtain a comprehensive data set from a single mobilisation. Whether you want to capture your defects and your assets, you can do it all from one mobilisation, therefore improving efficiency and ultimately saving money. Now, a little bit about our software. How do we take that digital video and how do we present that to our clients? Now, some of you may have been familiar with the Roadshow platform. From January 2026, Impulse Geophysics Roadshow, as you know it, is now known as Socotec Connect Roadshow. Essentially, this is a rebrand. All of the functionality still remains the same, and the software is now available in two major formats. So our online portal and our offline standalone application, which most of you will hopefully be familiar with. So as more of us have now adopted a more flexible working environment, obviously the pandemic we had in 2020, we developed an online portal which allows users to access their survey data from anywhere, anytime, without the needing a physical copy of the data. The benefits of this is that 4K video can easily become several hundred gigabytes and in some cases terabytes of data. And with us hosting all of that in the cloud and presenting it, it eliminates the risk of data being lost through USBs or hard drives being misplaced. The offline version, which some of you may be familiar with, is still very much available on one of our core deliverables. But like I say, this is usually in a hard drive or USB format, and therefore that needs to be loaded onto the client's servers or the client's data share formats. Similarly, like I mentioned, this is a bit risky as those hard drives and USBs can sometimes go walkabouts. Both platforms still provide the ability to view, interrogate and manage your data easily. The online platform now has around 95% of the functionality of the offline platform. So it's a great portal to be able to use going forward. So the functionality within Roadshow goes far beyond simply just watching video footage. It allows you to carry out a whole range of inspections directly from the safety of a desktop study. So the users can typically, you can simply view the multi-angle video, looking left, right, forwards, backwards, and our proprietary downward facing camera. Allows you to take in-frame measurements to measure and locate assets and defects and geospatially place them within your inventory. It also helps to build a bit of a digital understanding of the site. So it's often beneficial before you even put boots on the ground to get a video survey, to get a general idea for the site. It can also be handy for passing on instructions to traffic management should there be future works on the scheme. You can simply send them, crop out a screenshot, I want my traffic management to start here, etc. Allows you to capture new information. So build an asset inventory, build an inventory of your defects. And then on the back of that, we can also load in existing data sets for you to query, analyze, close out, modify, delete, etc. One of the other things that we like to do from our Roadshow platform is we perform our VCS surveys. So this is the CS229 Data for Payment Assessment Reporting Standards. We don't need to go out on site. We use our 4K video and export all of the defects as per that standard. The typical outputs from Roadshow for assets and defects, we can output them to CSV spreadsheets, shapefiles for your GIS integration. And generally, as the software is completely written in-house, we've got flexibility to report them to whatever requirement you need. Ultimately, Roadshow acts as a bit of a bridge between the raw survey image and being able to make accurate decisions about your data and future planning. A little bit on general inspections. So one of our simplest uses in the video, essentially, is just a general inspection. In many cases, traffic management, as we know, is or physical access constraints make on-site inspections difficult, expensive, and unsafe. So digital imagery allows engineers to review infrastructure remotely, essentially. Examples of general inspections could be bridge joints, which you can see on the example image there, parapets, boundary fencing, vegetation encroachment, so you can plan vegetation clearance, drainage features, and other roadside safety elements that are critical. Many of these general inspections benefit from repeat surveys, which allow you to continuously monitor the environment that you're looking at. So rather than relying on a single or periodic site visit, clients can track change over time and identify deterioration earlier, which ultimately leads to proactive planning of your network. Asset management. Now, this is possibly the best use of the Roadshow software and our most popular use of the Roadshow software. So it allows users to create, edit, and maintain their asset inventories directly within the platform. Assets can be captured in 3 main formats. So we have point features, such as signs or lighting columns, essentially assets that have a single GPS location. Linear features, such as barriers and fences. These are assets that typically run from point A to B. And area features, such as hatchings or chevrons, areas that essentially have a square meterage that can also be calculated within the software. The mapping interface on the online version sort of acts as a mini GIS with multiple toggleable layers and asset-specific attribute tables, all of which can be customized to the user's requirements. We would typically take a starting snapshot of any asset database, load that in, create all of the fields that are required, and then we sort of hand it over to the client for you to manage your defects in there. Some examples of commonly managed assets that we look after: traffic signs, lighting columns, VRS systems, pedestrian guardrails, and potentially some other roadside furniture. The benefits of this are that we, in development, which I'll touch on a little bit later, with API integration directly from our online platform into major PMS systems. So the systems you're already using, maybe Confirm, maybe Agile, maybe another one. We're looking at API integration directly between the 2 systems so that you've got a constant mirror between the 2. One example of asset management is, as I've spoken about, is signs. So using the 4K imagery and why it's so valuable is it allows the engineer to just confirm an asset exists, but also assess its condition in detail at that snapshot in time. So this example, looking at a traffic sign, we typically would break a traffic sign condition down into 4 categories. So you've got the sign plate condition, things you're looking for on this, potentially graffiti, bent corners, fading, denting, peeling letters, etc. We also look at the post condition, so the visible post that we can see. Again, is there any surface rust? Is the post leaning over to one direction? We can make that decision. Additional lighting, this is if there's any additional lighting that's illuminating that sign. Now, we typically can't assess whether the light itself, the bulb itself, is working, but we can get a good idea if the light's, for example, sagging or not illuminating the sign as it should. And also the obstruction of the sign. So completing a survey at set times of the year, we can see how excess vegetation affects the visibility of the sign to the road user. And because this imagery is all georeferenced, every condition that we assign to a sign can be tied back to an existing location, providing strong evidence for maintenance decisions. And the benefit is, like I mentioned, all of this can be done from the office, and images can be fully extracted and retained for auditing and reporting purposes. A little bit about defect management from video. So this is another popular feature of the Roadshow software. So traditionally, defects require operatives to walk the network, often under traffic management, which we know sometimes isn't possible. However, with the digital 4K video, defects can therefore be identified remotely. What we have, it's very similar to assets, but instead of an asset, it would be a defect. So we have all of the defect types listed in CS229 that are available within the Roadshow software, so that you can monitor, close out, or plan maintenance around those defects. We can load in existing defect databases for that purpose. So repeat surveys here allow ongoing monitoring so that defects and deterioration can be tracked over time. Typically, we'll do a sort of before and after. On many of our major networks for our clients, we do annual surveys, biannual surveys, just to track these defects across a period of time. And like I say, similar to the assets, fully customizable. So the client can only display what they need. They can only display the defects that they need, or potentially the attributes that are assigned to those defects that matter the most to them. And again, this is potentially integratable with your existing PMS system via dynamic APIs. Now, off the back of defect surveys, obviously comes a visual condition survey, or VCS, as they're more commonly known. So these inspections are undertaken in accordance with CS229, providing a structured and consistent assessment for highway condition. This process involves identifying defects within the Roadshow software, classifying them by type, assigning them with a condition severity, which then produces a clear evidence-based output as we accompany them with actual imagery. The survey is completely non-intrusive, no need for lane closures or operatives working live on the road. Each defect is supported with photographic evidence, scheme reference chainage, and geospatial referencing as well. So there's a whole database that sits in the back behind a typical report, which is nominally paper-based. And the benefits of a visual condition survey, obviously, it gives the client all the information they need so they can prioritize their maintenance, plan any future budgeting, and any long-term asset planning. Another development in the UK, specification came out in 2024 with the first trials happening last year, is PAS 2161, which is a bit of an important development within the highway sector. It sets out a consistent approach for commissioning and delivering highway surveys, specifically to local authorities, where traditionally only scanner was the acceptable form of surveying and providing the results. The goal here is to ensure that survey outputs are reliable, comparable, repeatable, and essentially fit for purpose. So at Soccertech, we've been delivering more visual condition surveys and looking at defects on the carriageway since around 1995, previously with Impulse Geophysics. This began with traditional on-site inspections, moved into HD video, and now 4K resolution allows us to capture more defects in higher resolution. So by combining experienced engineers with AI tools, we're looking to become fully compliant to the standard this year as the compliance audits happen in the spring and summer. There's then another area that we do here, and is very popular on highways inspections, especially at traffic speed, is our ground penetrating radar. So collecting GPR at traffic speed removes the need for road closures, and it also means that data can be collected in the daytime with accompanying video, which also helps for positioning that GPR data. GPR surveys allow us to assess pavement layer structure, subsurface condition, all without having to excavate the carriageway. Our GPR surveys are perfectly complemented with our video surveys. Like I mentioned, we like to collect it during the daytime hours. Both data sets can then be integrated into our online roadshow Socotec Connect platform. What are the benefits of GPR? It provides our clients with a good snapshot of surface condition when accompanied with video. The GPR provides structural layer composition, subsurface anomalies, any moisture that's present in the pavement, and similarly any voiding. And similar to our video software, our system is fully modular, allowing different frequency antennas to be used depending on the application, often within the same survey mobilization. So a little bit about the GPR specification that we use on our carriageways. So typically we would use an 800 megahertz antenna for a pavement thickness investigation. This gives us an effective depth down to around 1.5 meters, and is great for looking at layer thicknesses, void detection, moisture assessment, and sort of general structural evaluation. We also use a 1600 megahertz antenna or 1.6 gigahertz antenna, which is used predominantly to look in the bound pavement layers. So we're looking at each individual layer of bituminous or of concrete pavement. However, these frequencies will only go down to a effective depth around 0.45 meters. So in summary, lower frequencies provide deeper penetration, while higher frequencies provide finer resolution for the shallow layers. And there's just a little bit there around other antennas that we can apply depending on the application. For example, to look at a bridge deck, we would use a 1.6 gigahertz or 1600 megahertz antenna to really dig into those bound pavement layers on the top of the deck. Flexibility that we have within our system makes the GPR a powerful tool for pavement investigation and long-term network management. A little bit about how we handle our traffic speed GPR and how we process that data. So once the data is collected, we obviously have to process that using our proprietary tools that have been developed here at Socotec UK. So typically a raw radargram that's collected contains quite a bit of noise and quite a lot of artifacts that need to be removed so that it can be analysed for what we're essentially trying to find for the client. So our typical workflow, we do a time zero correction. This aligns the signal to a known reference point, in this case is the carriageway surface. We then put it through a bit of background removal, filtering out horizontal noise, some minor gain adjustments, and then we apply filters such as bandpass and dwell features, which remove noise, low and high frequency noise, which can mask the signals of the pavement layers. So how do we interpret our radar? How do we take it from raw, process it, and then what do we do for? So what we're looking for in GPR is strong continuous reflections, often representing layer boundaries, such as an interface between asphalt and base layers, or in the case of a 1.6 gigahertz antenna, the interface between the individual pavement layers. We then look for the signatures within the GPR. So hyperbolic signatures can typically signal voiding, utilities, rebar, or any other buried feature. Now, without the need for intrusive testing, we have a depth estimation to approximately around 6 to 8% on most pavement types found in the UK. However, this can then be improved further with any pavement cores, excavation records, or any velocity modelling techniques such as common midpoint analysis. Essentially, we can take fewer cores in the surface and we can extrapolate that data across a much longer stretch of road. GPR, data analysis and interpretation. So looking at pavement layer thicknesses, we're looking at moisture content, we're looking at voiding. We're also looking at debonding and delamination within the pavement layers. We can also look at voids or any air and water-filled gaps within the pavement, and cracks or reflective anomalies, disruptions in the continuity of the reflection stand out. So the key advantage is that we assess these carriageways non-destructively, and then we can carry it out and extrapolate that over a much larger area. So how do we present that data? I touched on it a little bit earlier. We present that data alongside our video, which sits within our roadshow software, which is why we like to collect in the daytime. This gives you a good indication of what is going on above the surface and what's going on below the surface. So for example, a reflective crack located on top of the surface, you can then dive down to see what's going on beneath, whether any excess moisture has seeped into the pavement, or essentially if there's any underlying conditions that have happened in there. So that's a basic preview summary of our video and our GPR highway surveys. I'm just going to talk a little bit now about products that we've got in development, future pavement developments, where we are with AI, and what the future of AI is within Socotec and within the highways. Current product we have in development is our automatic defect analysis and VCS reporting. Typically, a VCS reporting is quite a slow process, picking the defects and then logging them within a strip plan and a formal report. We're looking at how we can streamline these and cut out the 2 steps of creating the strip plan and creating the report. So all you have to do is pick your defect in the Roadshow software suite, press export. That then goes through some clever algorithms to quickly and accurately export all the required outputs for CS229 VCS reporting, essentially making things a lot easier, and also it reduces the possibility of human error when translating that data. One of our future pavement developments that we're looking at is the use of drones for asset and defect management. Now, Roadshow works in the exact same way as when handling drone video as when it does when handling carriageway video. Essentially, it's just a different video stream that we can have geospatially and distance measured frames extracted from. Some of the advantages of this: cover large areas in less time. You can give you a much larger overview of the carriageway rather than as opposed to a single lane or the adjacent lanes to that. And essentially, it's great for mapping things like joints or other locations. Not sure what I've done there. It's great for mapping joints on exposed concrete pavements. However, there are some potential drawbacks to that, in the sense that there's quite tight regulations about flying drones around highways at the moment, and obstructions due to travelling vehicles at the time of filming. There might be a crack under a vehicle, for example. Okay, next slide. So our current approach to AI. So AI is a bit of a buzzword, as you know, in the industry, but what really we are doing here is a method called machine learning, which is a subset of artificial intelligence. That essentially enables the system to learn from real data, identify patterns and improve performance over time without being explicitly programmed itself using an AI model. Currently, this applies to images specifically in our use case, but it can be used to understand and interpret specification documents such as PAS 2161 and CS229, making a powerful tool when you apply it to highways. So typically, we will annotate an image, we will annotate a crack, we will annotate a pothole. We will then feed that into a training environment, which will then give us an outputted model. That model is then run again on another 1,000 images, another 1,000 frames to see if it's correct. We can make any annotation changes, and then that just feeds round and round until you've got a really highly accurate model providing what you're looking for. Current AI capabilities within Socotec. So one of our main is road stud detection and retroreflectivity analysis. So I touched on our night video surveys earlier. So using specifically calibrated cameras, we've calibrated to a popular Zetna system, which is used for measuring the retroreflectivity. We can locate your road studs on your network that are working, and give you the color and the retroreflectivity value of those, as well as their individual GPS location. In the image there, you can see that we've mapped a lot of road studs, so you can see the clear areas where road studs are potentially missing. And you combine this with a daytime inventory of your road studs, which will have all of the present and the missing stud locations. You can then quite easily do a lot of analysis to see where your hotspots are of missing studs and where areas of your network are performing poorly. Sticking with the nighttime video and the retroreflectivity, we can take measurements from night surveys to, again, using specifically calibrated CCDs of the cameras, again, to a slightly different piece of retroreflectivity equipment, but we can take the retroreflectivity of the sign as a whole. Now, the benefit of this over the traditional retroreflectivity gun is that we take a reading from the whole sign, and not just a small section that you point the gun at, which is usually in the easiest to reach part of the sign in the bottom right-hand corner. Another benefit is using the gun, you're instructed to clean a small area of the sign, which is not really giving you a true representation of what that sign is reflecting to the road user. Again, when combined with a daytime survey, you can get your ratings, as I touched on earlier, for a traditional sign survey, combine those with your retroreflectivity, and you've got a much bigger picture of how your signs are performing. Another AI capability that we've got is you detecting all of your on-carriageway linear assets. So these could be longitudinal lines, transverse lines, arrows, words, hatching, chevrons, box junctions, all from one part of the vehicle. Now we can combine essentially one driven survey at night. We can apply all of those three AI capabilities to, so traffic signs, road studs, and carriageway markings. We can apply all of those models to one single driven pass of video. Current AI project that we've got in development at the moment. So automatic detection of off carriageway assets and also on carriageway defects. Now these are two separate approaches. So off carriageway asset detection, looking at automatically detecting the signs and putting them into an inventory. It's easy to auto detect the sign, but we've applied a bit of logic to look at giving it an actual classification, because just finding a sign is okay, but we need to know what that sign is, how big that sign is, the mounting methods, etc. Like that. So we're looking at a little bit more information around just the sign plate. Other areas of off carriageway assets are lighting columns, locating lighting columns, and also excess vegetation. Can we spot excess vegetation using AI to give the reports rather than having to manually traipse through video data to find that? And on carriageway defects, this aligns very similarly to CS229 specification, looking at your typical carriageway defects, your cracking, your pothole, surface deterioration, fatting, fretting, etc. Another future AI opportunity is around concrete and metal VRS inspections. So lots of carriageways now are transitioning, a lot of major trunk road carriageways are transitioning to concrete barriers. However, with concrete, you do get a certain set of defects that come with that. Now, using cameras that's modular and pointed directly at these assets, we're looking to use AI and machine learning to spot defects and map these defects in real time. So examples on concrete VRS, you're looking at cracking, crazing, any joint damage, and steel VRS, essentially looking at damaged posts, missing bolts, any corrosion, any dents, or any previous accident damage, essentially. Just getting to the end a little bit now. Highway surveys, we sit within a division here at Socotec called Monitoring and Surveying, of which we've got so many other services that can complement our video and GPR traffic speed surveys. We have a structure and pavements department that we work very closely with, These deliver specialist assessments and testing across the road infrastructure, bridges, other assets, structural investigation, load testing and analysis, coatings, inspections, concrete fixing assessments, to name a few. We have a geotechnical and structural monitoring team as well, and they're responsible for installing and managing our geotechnical and structural monitoring systems. These can be cameras, tilt systems, vibration monitors, looking for various things on your network. And then we have a test pavement and materials testing department as well, which support highways and pavement projects, normally with lab testing, looking at CBR, plate load tests, asphalt compliance, soil and aggregate evaluation, etc. What we're working with is we work very closely together here at Socotec, and we're looking at how we can integrate all of our surveys that we bring together. So for example, if you have a bridge report done from our structures team, can we load that report into Roadshow Online? It's GIS system, so that you've easily got all of your data accessible in one place. Similarly, if you've got 20 monitors on a cutting at the side of your carriageway, on the online Roadshow, we can load those into there, and then that will be able to have a quick, easy, launchable link into our Blue Trust monitoring system. And yeah, to bring everything together, digital highway surveys provide a safe, reliable and repeatable way to assess and manage your road network. Here at Socotec, combining 4K video, geospatial data, GPR and emerging AI technologies, we aim to deliver high quality information without disrupting traffic or putting people at risk. Thank you very much for your time.